Hey there, I hope you're having a great day. Today we're going to check out factoring. Wait a second, we already did factoring. But we're going to do factoring with what's called difference of squares. I'm simply going to ask two things of right now. The first thing is that in a second that you simply pause the video. And the second thing is that you try the box method, the area model, on these three problems. So if you could go ahead, pause the video, try the box method on these three problems, then come back and we're going to talk about what happens. Okay, cool. I hope that you paused, and welcome back, and thanks for putting in the effort. Let's take a look at what happened back and write the answers of 3x plus 4, 3x minus 4. Notice something as I am just saying these answers. 2x plus 5 times 2x minus 5. And on the black one, x plus 3 times x minus 3. Hopefully you noticed the pattern. Both of the factors are the same exact thing, except for one of them has an addition sign in the middle, and one of them has a subtraction sign in the middle. So what's happening? Well, let's go back to our definition, or what we're doing here. We're factoring. Cool, we did that before. We did the box method. There's other ways to do it. Difference. Difference means subtraction. We got minus the 9. We have minus the 25. We have minus the 16. When I go and factor a negative number, that has to be, like for the negative 9, a 3 times a negative 3. And I could try 9 times negative 1 and 1 times negative 9, but we'll talk about that part in a second. The negative 25 is a 5 times a negative 5. We see that happening. And then negative 16 is 4 times a negative 4. So why do we keep choosing the same numbers here? Well, it's called difference of squares. And if you look at all of these problems, they are difference problems or subtraction, and they all have squares. Do you know that 16 is a perfect square? 4 times 4. Do you know that x squared is a perfect square? X times x. Do you know that 9 is a perfect square? 3 times 3. Do you know that 25 is a perfect square? 5 times 5. X squared is x times x, and 4 is a 2 times 2. 9 is 3 times 3. The 0 really shouldn't be there, but 0 times 0 is 0 anyways. And then x squared is a perfect square, x times x. So if we have perfect squares, x squared comes from x times x. And then negative 9 comes from positive 3 times negative 3. I really don't have to worry about the tricky part of the boxes and factoring. I just got to worry about the x squared and the minus 9 and make sure that it balances out so that these two boxes over here cancel out, and it's the same on both sides. Cool, let's see here. In black, x squared plus 0x minus 9. I've set up the x squared. We know that that is x times x, and that I'm going to get some x's there and there. So the only spot for the negative 9 is catty corner. X squared times negative 9. We go across that diagonal. We list all the factors, and boom, there is 3 and negative 3, the combination, which gets us back to that 0x squared. So I need to put 3x, and negative 3x, or 3x minus 3x is 0x. Cool. So then I need an x and a 3, and then an x and a negative 3. Cool. We'll go ahead and leave it right there. We'll come back to that in a second. Let's go ahead and take a look at the purple one. Hopefully you already did. 4x squared times negative 25 is negative 100. X squared, there's a bunch of factors of negative 100. And really what's kind of missing in this problem is the 0x, but that's what we're looking for. How do I get 0 x's? Well, I need a positive number of x's, and I need a negative of the same number. 4 doesn't go into either of these unless I do this with decimals, and in factoring we don't really take a look at decimals. Do you notice that a 2 is a common factor? 2x times 2x gets 4x squared. 2 times a positive 5 gets that 10, and then you got the x. 2 times a negative 5 gets you negative 10, and then there's the x. And then in the last corner, that comes from the 5 times the negative 5. Cool, I'll leave that work there. We'll come back to that answer in a second. And 9x squared is ridiculous. Times negative 16 is negative 144. I didn't even list out all of them. I just listed out the negatives on one side, but really I should be putting negatives on the right side as well and repeating this whole list. But there are no x's in the middle. So the only way to get 0 x's is the same number with one positive and one negative. So if I put in 12x somewhere and minus 12x, that takes me to 0x. So 9 doesn't go into 12, but you'll notice that 3 does, and x is also a common factor. How do I get 9x squared? That is 3x times 3x. How do I get from 3x over to 12x? That would be using a times 4 or a positive 4. And how do I get from 4 down to negative 16? That's a negative 4, and that also matches up my last box there. Cool, so I'm going to go ahead and that strategy on a couple of trickier problems. Let's take a look at the green problem. 36x squared, okay, that's a perfect square. 0x in the middle, that is the key. And then it's a difference, it's minusing another perfect square. So it's a difference of perfect squares. We are ready to go right to our answer. We don't need that box method anymore. How do I factor 36x squared so it's a perfect square? That would be 6x times 6x. How do I factor 25 so it's a perfect square? That is 5 times 5, but it's negative, so I need a positive times a negative, and I am done. Notice the instructions up here just say factor. It doesn't say factor difference of squares. They're not always going to tell you. Sometimes if you just notice this pattern, it will shorten the process. 49x squared. I know that 49 is a perfect square. 7 times 7. X squared is a perfect square. X times x. 9 is a perfect square. 3 times 3, but it's a negative 9, so I need a positive times a negative, and I am done. No boxes necessary. 100 is a perfect square. X squared is a perfect square, and 1 is a perfect square. 100 is 10 times 10. X squared is x times x. 1 is 1 times 1. I can do negative times positive. It doesn't matter what order I go in, as long as I have one positive and one negative. Cool. How do I factor 81x squared? That is 9x times 9x. I need to get a negative number, so that will be a positive times a negative. And it doesn't matter if there's a number over here or a variable. If we're looking at an honors problem, it's y squared is simply y times y. So difference of squares problems, again, you want to be factoring something that has 0 x's in the middle. Sometimes they will list it, sometimes they won't. It needs to be a difference, meaning that it is a minus problem. There's a subtraction problem. And it's difference of squares, squares plural. So I need to have a perfect square at the front and a perfect square at the end. And that is the end.